There we go. Sorry. I have a new headset, and OBS hadn't recognized it yet. My other headset, the plastic started to crack because I have a giant friggin' head, and it does that to headsets. Yeah, should be good to go now. Probably if anything, I'm a little too loud. All right, so today, cats please. None downstairs, but I'll go ahead and just again left to right. Morgan, uh, Stewart, and Colby. Yeah, well, the problem is Turtle Beach is not good. But you try to buy a headset right now, and you tell me how much luck you'll have because it's difficult. I did had no intention of getting Turtle Beach, but it was literally the only thing I could find. GameStop had one. I was able to pick one up. Yes, HyperCloud is great. You're exactly correct. Try to order one right now. Because try to order a webcam and a headset right now. Let me know how that goes for you. It last I checked, Amazon is saying expected delivery end of May, and my headset was breaking last week, so I didn't have that long to wait. With that, yeah, I don't like Turtle Beach. I prefer HyperX, but it's what GameStop had. Best Buy was out, um, and I was seeing like end of May shipments. Anyway, so today we're just going to jump straight into the final exam review. Get a sponsorship. Pretty sure that violates more than one ethics rule if I get my lecture sponsored. Um, my or oh, because I have this recovery thing up. There we go. All right. So, homework 6, as a reminder, is due tomorrow. I've actually seen this is like the first homework I've seen this where like more than half of people have submitted as of today, last I checked. So that's good. Uh, as a reminder, the advantage of homework 6 is you know what your score is as soon as you submit it because it tells you, and that is your final score. There is no manual grading. Homework 5, last I checked, there are about 15 left to grade, which are getting graded as I speak. So homework 5 scores should be out later today, and by later today, I hopefully mean within the next couple hours. So from then, homework 0 through 4 scores. Homework 0, the scores are only on Colab. Homework 1 through 4 on WebCat. The denominator is 700. Once you have all your grades, add up the total, divide by 700. That's the homework component of your score, and that's 25% of your grade. You can see the grading breakdown on the syllabus. That hasn't changed. The reason we haven't uploaded the scores from WebCat to Colab is that if there's a regrade, it leads to a desync problem where we will have to constantly re-download and re-upload. So I will probably upload the scores to Colab here over the next 2 hours. But if you submit a regrade, that won't get reflected immediately. It will be reflected before we do the final grades, but it won't be reflected immediately because I'm not going to download and re-upload the scores every single time a regrade request goes through. So do be aware of that, but hopefully you should be good to go soon. Course evaluations, extra credit opportunity. You know how we said there's no extra credit in this class? We lied. I like lying to people for fun. It's why I go by my middle name. Anyway, the point is, we do actually want your feedback. We do care, and I know that let's call this semester a touch unusual. But we do actually want to solicit feedback, not just about how we did transition class online, but even from before online, just the whole course. To that end, the evaluations are up today. If you submit by Friday, May 1 at 11:59 p.m. Technically, it's more chaotic neutral. I didn't say the lies hurt people, like the fact that I go by my middle name. Um, you will get a 1% bonus to your final grade. I want to be clear, 1% additive bonus. If your final grade were a 92.3, it becomes a 93.3. Remember how we said we don't round up your grade? This is basically the way that you can get your grade rounded up. Please do the evaluation. Please take it seriously. Um, I will say that we do read the feedback, and most feedback is usually good. I have had people tell me they wish I was burning in hell alone before. The alone was the word that got me. No one else was there. Seems like Pol Pot should be there, but whatever. Please don't say stuff like that. It's, we do want feedback that actually helps us improve the course, and telling me I should go to hell, while maybe cathartic, doesn't actually help us make the course better. Um, to that end, we will see at Friday at 11:59 p.m. We will download the list of every student who has responded. We will not see your response. Your response is anonymous, but we will see that you responded. We won't see the results until the end of May, so there is no. The survey, is it on Colab? Yeah, I believe so. I believe on your Colab home tab, there's a course evaluations tab, and that's how you take it. So again, this won't have any impact on your grade other than the 1% bonus. But this is by this time, Friday, May 1, 11:59. If you forget and do it later, there is no opportunity to get that 1% later. So you could even do your course evaluation today if you would like. But please do it. Format of the exam. The exam will be available from 12:01 a.m. to 11:59 p.m. the entire 24 hours Saturday, May 2nd. As a result of this, even if you have another exam in the 7 to 10 slot, our exam's considered take-home by the final exam rules. So that alone will not warrant a makeup. You are expected to take the exam this day, given that you are given the full 24 hours to take it. Same as exam 1 and 2 in terms of format, multiple choice and coding questions. Open notebook, internet, IDE, etc. Because if we try to restrict that, we're frankly only hurting honest students. So to that end, though, it is still individual, no collaboration. We do cheat check the coding submissions to see if people are sharing code. So be aware of that. No questions about the exam answered on exam day. It's the same rule as exam 2, and the reason for this is if someone takes the exam at 9 a.m. and then someone asks a question at noon that makes us realize there's a typo, if we fix it, everyone who's taken before we fix it has taken a different exam, and it's not fair to them. So as a result, no questions on exam day. About the exam, about any class material, etc. We won't answer any questions. Do we fill out the eval for the lab portion as well? Yes, please do so. I should note the extra credit is only for your lecture section, but yes, do please fill out, because the lab evals help us kind of give TAs pointers to help them improve as well. All right, so from there, I mentioned some ground rules for today. I will put those back up, and I'm just going to quickly repeat them. So first, I will answer in the next 5 minutes any format questions you have. I feel I've covered it, but I will happily answer any format questions. However, don't ask, will blank be on the exam? Unless the study guide explicitly says blank won't be on the exam, which there are places it says that, then you can assume that that thing is potentially on the exam. So for example, and how to get the asymptotic runtime complexity of a recursive function, that is not on the exam because we haven't covered that in class. That was one of the things we had to cut down on. Swing graphics, so GUI elements, will not be on exam 3. Event-driven will be, but not specifically swing elements. Pretty much everything else in the class that we've covered is on the exam. Going back to the ground rules. I cannot reteach a lecture during this stream, and I'm not going to try. So try not to ask, can you go over incredibly broad topic here? Don't ask, can you go over binary search trees? No. That was like a full day of lecture, and I'm not going to do it. But I'm very, very happy to answer specific questions, except I'm not actually willing to help overly much, specifically binary search tree because of the homework. But broadly, I can at least illustrate things, etc. I don't know how hard the exam is because it's not written yet. That was already answered. The answer is there style grading on homework 6? Your score that you're given is out of 100. That means there are no points in there baked in for style. So, and in fact, I think that's written clearly on the assignment and on the Piazza post. So I feel that question's kind of self-evident. I don't know how hard the exam is. I don't know how long it is because it's not written yet. But even if I did, I generally don't say because what I think of as hard is different than what students think of as hard because of just different experiences with the material. I don't know what percentage is on earlier exams. What I will say is this. While I'm going to focus on this slide on post-exam 2 content, at the end I will open up for pre-exam 2 content. I would say that it's anywhere from 25 to 60% of the exam is pre-exam 2 content. And I know I gave an incredibly broad range there, but again, hasn't been written yet. The exam will have more material from post-exam 2 than it will from any of the 2 individual components before. That much is certain. But this exam is cumulative. I don't know where people ask this, so so we only get 2 hours to take the exam instead of 3. That is correct. The exam time limit is going to be 1 hour and 20 minutes. If we find the exam is longer, we can change that before exam day, but we are aiming for a 2-hour exam. And the simple reason for that is if the exam's going to be 3 hours, we have to add more questions, which adds a fatigue factor, not just to us, but to the students taking the exam. So 2 hours generally tends to be a better time limit, because then we write the exam basically for students to typically take 2 hours. All right, any other format questions? That is written on the slide. You can see it here. And I did answer that question already as well. Surveys can be found on the homepage. Thank you for that. Any other questions about the format? All right. So let's start by iterating through the post-exam 2 content. So initially, we talked about ADTs and we talked about stacks and queues. We also talked about concurrency. This was, keep in mind, after algorithms, which was on exam 2, but algorithms certainly will be on the final exam as well. So we talked about how to do constant time stacks and queues. So remember that an abstract data type is just an idea of a structure. For example, a heap is an abstract data type. Now, we implemented a heap with an array. The second I say I'm implementing a heap with blank, any implementation, that is no longer abstract. The abstract data type is the idea about what a heap is. The actual implementation of a heap, whether you use a recursive linked data structure or whether you use an array, that makes it concrete. The abstract data type is just the idea of what a stack is, or what a queue is, or what a heap is. The second you start implementing it, it's no longer abstract. And so you can't do algorithmic analysis on an abstract data type, because algorithmic analysis requires judging and implementation. And the second I say the word implementation, we're no longer abstract. We're concrete instead. And again, concrete is the opposite of abstract. I can describe the idea of an energy drink, and that would be in an abstract way. It's a drink that peps you up or maybe staves off the caffeine withdrawal headaches that you've been dealing with for the past 10 years. Or I could hold up this energy drink here, which no, I'm not going to advertise because that's not that kind of stream. But that is the base of an abstract data type. Are there any questions about abstract data types, stacks, or queues? Actually, don't know how many people are even watching right now. Maybe I don't have a lot of people watching today. Let's see. There we go. Now I didn't have my my OBS thing open. Okay, so that's actually, this is one of the smallest classes I've had here, because typically it's been like 130. That's interesting. I expected exam day. I expected this to be just like 190 people, 60 of whom haven't watched a lecture since like we've gone online, but I guess not. All right. Concurrency. So we've talked about threads, runnable, lock, conditions. Hang on, are what generic? I just because I just switched topic, so I want to be clear about what you mean by they. Just stack and queue. They can be, sure. So we implemented a stack and queue that was not generic, if I remember. If I remember, I think we just use integers. But you can implement a stack and queue generic. Understand that when we're talking about a stack or a queue, I'm not talking about java.util.stack or java.util.queue even. I am talking broadly about the idea of a stack and a queue. And in theory, a stack and a queue can hold any data type. You can therefore, because in theory you can make it generic, in code you can have a concrete implementation that's generic. That's the power of Java generics, is it lets you do that. But again, the idea of a stack and a queue is abstract. It's, first in, first out for a queue, first in, last out for a stack. And so those ideas allow for generic. I just realized my camera's a bit off center and I just made it worse. There we go. But I mean, certainly they can be. Certainly you could implement something like, stack E or Q E, and there are Java implementations that do this. But yeah. Again, it doesn't mean that all stacks and queues are like this, because a stack and a queue, the same as a tree, the same as a linked list, they're ideas that Java didn't invent, that Java doesn't have ownership of, that you can implement in any programming language. In theory, you could even implement it in Brain. It starts with F, but it would be imaginably a time-consuming task, and I wouldn't personally try to undertake it. But in theory, any language could implement those behaviors. All right, any questions about concurrency, threads, runnables, locks, conditions? Sorry about the chimes. I've turned off every Windows notification sound option I can see, and it doesn't turn off. No questions about concurrency? Can you give an example of race condition? Sure. So we actually gave one in class. So, with race conditions, the problem is that, and while I'm pulling up Eclipse, I will go to the whiteboard, which is currently showing off a very fun board game called Battlecry. But now my mic is, hang on. You're going for a ride. I hope you enjoy. All right. Sorry about that. Hope no one got too dizzy there. All right. So the race conditions emerge in the following situation. Let's say that I have two threads calling a function at the same time. I have some function. I don't really care about the name, but it takes, and let's say that the class has some int field x. And I have a function that just does x plus plus. Now, you may think this is one line of code, but at a compiler level, this is three separate lines of code. At the root level of the processor, this is effectively three lines of code. This is, first, get the current value of x. Of x. And this is at assembly language level. This is add 1 to that value. And then it's store that value back in x. At assembly language level, this is effectively what happens. Let's say that I have two threads that execute this at the same time. So I have T1 and T2. And I'm actually going to number these lines of code as 1, 2, 3. Now, it could be that if these two threads run over this code, that first we get 1, 2, 3. So let's say x was 5. We run this function, now x is 6. And then 1, 2, 3, we run this function, and x is 7. So if x was 5, and then we increment, and then increment, we end up with 7. Another possibility is that x is 5. This marker's dying. That x is 5, and we execute line 1, and then we execute line 2. So this is holding now the value 6, and it's waiting to store the value 6 back into the x value. But then we get interrupted, and we come over to T2, and we do 1, and then 2, and then 3. Well, what is the value of x at 1? It's still 5. What is 1 plus that value? It's 6. So we take that 6, and we store it back in x. And remember, this is my x value. So now it's 6. Then we return over here, and we finish up that third part. And it is x equals 6. Well, we're just going to take 6 and store it there. So notice we've incremented twice, but as a result of this, the value of x is still 6. Let me just take... Just because we have multiple threads doesn't mean you need locks. Correct. It's only when there's a shared resource between those threads that is being written to by those threads. So that's an example of a race condition. And if you want another example, you simply need to look at, and let me close this real quick. You simply need to look at, for our thread code that we uploaded, it's thread example 4. So thread example 4 intentionally has race conditions. This intentionally does not work. If you run your bank account thread runner, this is intentionally going to not work. I'm going to end up with a final balance that is not 0, even though I did the same number of deposits and withdraws. And so that's because I have no lock protection here. So because I have no lock protection, this is the problem that I end up with. And I do see there are other questions. I'm just trying to thoroughly answer this question before I move on to the others. Whereas in thread example 5, which again, this is uploaded. Well, hang on. So there's you're asking a different question there. You asked actually two different questions, and so there's a difference between sufficiency and necessity, and I'm gonna get into that. No, so you're asking, you're kind of, you're thinking the question is saying something it's not, is what I'm getting at. So I'll get there, because the correct answer is true, but you don't always need it's not asking, do you always need locks if you have multiple threads? You don't. That's not what the question's asking. The question is asking, effectively, if you don't have threads, if you have no threads at all, do you need locks? And the answer is no. And so that doesn't necessarily mean that you always need locks if you have threads, but if you need locks, then you must have threads. Otherwise, you wouldn't need locks at all. So it's a little bit of a weird logic thing. It's basically there's an exist. Remember, the negation of always is there exists. And actually, you may not remember that if you haven't taken discrete mathematics yet, but that does come up a lot in formal logic. Anyway, so on thread example 5, we put these locks here, and these locks, oh, sorry, and these locks make sure that whenever we are inside of this lock, that the thread can't be interrupted. That is to say, only one, well, technically the thread can be interrupted, but it's that no other thread can enter this function until we have released the lock. Again, think of the dining philosophers I talked about. The idea is when one philosopher is holding a chopstick, no one else can get access to it. Sorry, my throat's a bit dry. And also I'm sleepy, hence why the energy drink. When would you use a condition? So I do want to be clear, just because I did see some confusion of this in chat. While the word's the same, a race condition actually doesn't have anything to do with the Java lock condition that we talked about. So we have an example of a lock condition in bank account 6, or thread example 6. And the idea is we have a sufficient funds condition. And the point being, when we deposit, we're adding money to the account. When we withdraw, we're taking money from the account. But we want to make sure that we never go below $0. Because the bank won't be happy if you withdraw more money than you deposit. So even though ultimately we're going to end up back at 0, we want to make sure that we never are at a point where we're below 0. We deposit and go up, and then we withdraw and go down. And we can bounce back and forth, but we can never go below 0. That's what we want to ensure. The thread example 5 has, it will go up and down and up and down, up and down below 0, and it will end up at 0. We want to go above 0 and be able to move up and down, but we never want to go below 0. That's like a hard floor. You can't go below. And so, the condition is used to prevent us within the threads from proceeding if we are in a place where we can't proceed. For example, in the withdraw function, we pick up the balance change lock. No one else can change the balance. But then we say, oh, wait, but the balance is less than the amount we're trying to withdraw. That is to say, if I perform my withdrawal right now, we will go below 0. And I don't want to allow that. And so what I do is I hit this await statement on the condition. And notice the condition is tied to this lock. We do lock.new condition to get this condition. What this means is temporarily release the lock. Don't sit on top of the lock, and wait until you are signaled. And when you are signaled, you can try to proceed again, but only when you're signaled. From there, When should we signal withdraw? Well, there's no point in trying to wake this thread up until we've deposited more money. Because once we deposited more money, hey, maybe we can do this withdrawal now. So once we've deposited that money, we then say signal all. This is going to wake up all the waiting threads and let them try to proceed. So they will try to get past this while loop. They will pick the lock back up. They will try to get past this while loop. If they get stuck again, then they once again await. What's the difference between signal and signal all? I'm not sure what you're asking. So we've never called the function signal. The only function we've used is signal all, and that's the only function you need to use. You don't need to use. So I'm saying signal as just a generic term. The function is signal all, which performs sending the signal. You may have seen it in the API. So signal can be used to signal specific things, but that gets way too into the weeds, and that's significantly harder than we want to get into. So the condition is used to limit how we proceed. Keep in mind, I'm just quickly looking. Why do we have a lock in the same method when using a signal? Because the lock is tied to the signal. The lock. Notice here is our condition. The condition, is tied to the lock. The condition is balance change lock dot new condition, and the Java rule is you cannot await nor can you signal all unless you possess the lock. So because the condition is tied to the lock, you have to have that lock in order to use await or signal all. And so that's why the condition dot await temporarily stops us from proceeding and tells other threads, hey, I'm waiting for something. Like if you've ever seen a guy, like, say, waiting in front of a building for a friend, they're just waiting for some condition to emerge before they, as one of the threads, students, this is a bad metaphor, but whatever, enter into the building. So they're waiting on some condition to be filled. They're still there, they're just waiting. And then once something that could alleviate that condition, say a student arrives at the door, maybe it's their friend, we can signal all for the person to check if that's their friend. But that is still tied to the lock. The condition is not an alternative to a lock. It is a way to utilize the lock to basically say pause and restart. Pause is await, restart all the waiting threads is signal all. If you have multiple locks, how does each know which variable is locking? It doesn't. The locks are completely ignorant of why they exist. The locks are like me in my 20s. I have no clue why I'm here, but I'm just a cog in the machine doing my job. Early 20s. Late 20s, I didn't. Late 20s, I had a goal in life. Early 20s, not so much. The lock does whatever you tell it to, which is to say, the lock says, this is a protected section of code. Think of it like this section of code is and actually not just this section of code, but also this section of code. These two sections of code are extremely exclusive nightclubs. They're the most exclusive nightclub you've ever been to, because there's only one person allowed in it at a time. It's actually kind of lonely and sad. It's a lot like, once again, me in my 20s. The point being, only one function can be inside the lock at a time. When you say await, that's like saying, hey, I'm going to step outside for a smoke break, but you don't have to wait in line with everyone else trying to get into the club. You just step out for a smoke break. Someone else can step in, and when they leave, they say signal all to let the people with their smoke break know, hey, you might be able to get back in. So you only need one lock. So I did in class go into why you sometimes might want more than one lock, and I did talk about that. So if you want to go back and look at that lecture, if you have multiple variables, it may be that those variables can be protected independently. That is to say, you have two separate locks for two separate variables, but it may be that those variables are tied together closely enough that you only have one lock for two variables. But certainly you should never have more than one lock for a single variable. So in general, we should use one lock for one variable or group of related variables. It depends on what you mean by related. By related, I mean tightly coupled. Which suffice it to say, generally, we're not going to throw this too much at you on the exam, but it's worth knowing that if you only have one lock and you have several independent variables, your code will be less efficient than if you have one lock for each variable. Yeah, how many people here miss waiting in line? It's all right. I never left my house anyway before all this started. All right. That is sadly true. Anyway. Sorry, I did miss this question earlier. Are locks normally placed in runnable or not runnable classes? So locks are actually not in the runnable classes. The locks are in the class that the threads are running on. So notice this is bank account. This bank account is used, this bank account is used by this thread runner class. And the thread runner class creates deposit threads and withdraw threads, but the lock is in bank account, not in the threads. The threads are controlled by the locks. The threads do not control the locks. They are controlled by the locks. Sorry, that was a very good question, but I kind of did get a bit overwhelmed responding to questions. All right, we're at 12:40 here. I will move on from conditions for now, but certainly I can stick around a bit longer. But with 10 minutes left in the official lecture period before I do unofficial, I want to at least try to hit everything once. Recursion. So there is one thing I want to note in the Colab exam review. Just because people see this and they ask questions on it, and I just want to make sure this is really, really clear. You may see asymptotic analysis of recursive code. Just to be very clear, this is not on the exam, nor is Section 5. It's because we just didn't cover this in class. We dropped one of our 2 days of recursion. That was the second day. So don't worry about that. But with recursion, remember, we are talking about a base case and a recursion towards a base case. You want to be able to look at reading recursive code. How could you parse a recursive function? And in the overtime that I plan to do, I'm going to give you an example of a homework that I gave to my intro programming students at Penn, which was used for a recursion tracing. And we can do that together to help each other learn. As well as, if time permitting, I'll give you a really, really hard recursion question that will be substantially harder than anything you see on the exam. But it'll at least help you think about how to do recursion. But that'll be in the overtime. Divide and conquer. Basically, all we talked about with divide and conquer was binary search, how to do that recursively, and merge sort, how to do that recursively. Any questions about anything here? I don't have a noise gate on this mic. One sec. You're probably hearing the crunching, and that's... No, my noise gate's just not very good. Okay, good to know. We tried. This headset already I don't like. Will the coding section be on something after exam 2? The coding section there will certainly be a coding question section. So there's either 2 or 3 questions in the coding portion, and either one 2 or 3 of them will be on exam 2. That is to say, at least one coding question is post-exam 2. Potentially one is pre-exam 2, but again, not GUI. And so, for context, pre-exam 2, the things we talked about were just basic Java intro, comparators and comparables, algorithm analysis, and inheritance structures. But pretty much all of those we've been using in more recent times. So it can, in theory, be anything we covered from the year, correct? But in terms of coding, the nice thing about coding is it's inherently cumulative, which is to say that if you're comfortable coding the post-exam 2 content, it's unlikely that you would struggle with pre-exam 2 content. I would say that if you've done homework 6, that your coding skills should be fairly confident for exam 2. That's not to give a hint about what the questions are. They haven't been written yet, and even if they have, I haven't seen them. All right, no questions on recursion. Data structures, so there's 2 slides. There's linked lists and there's data structures. I want to be clear that linked list it's actually a topic we added so we could teach something besides linked list. And here's what I mean by that. Last term, we jumped straight from recursion to trees. And like on the day we taught trees, we mentioned, hey, are there these things called linked lists? But we didn't actually explain them. The reason we taught linked lists was to teach you binary search trees and to help you understand node structures better, to give you kind of a warm-up of node structures before we jumped into binary search tree nodes, which are just more complicated nodes. I use my hands a lot. I'm watching myself on camera now, and yeah, it's probably annoying to everyone here. Anyway, point being, there's not a lot on linked lists to cover because most of that material is covered in the more complex binary search trees, but it's at least worth being familiar with linked lists. Again, if you've done homework 6, this linked list is almost trivial by comparison. I would say take time to make sure you understand in the code we uploaded the add function, not just add at the end, but add in the middle, the find and the contains function, that those would be useful to know. So binary search trees and linked lists use nodes, but heap use array. So technically speaking, a heap is an abstract data structure. Technically, so is a binary search tree. You can implement a binary search tree with an array, and you can implement a heap with a linked data structure. In theory, I would say that heaps are almost always implemented with arrays for various numbers of reasons. Binary search trees I've seen implemented both with arrays and linked data structures. But generally, for the purposes of the exam, you can assume that if we're asking you questions about a binary search tree, it is implemented like homework 6 as a linked data structure. And if we're asking questions about a heap, you can assume it's implemented as an array, like we talked about in class. Those are safe assumptions, unless we very explicitly say otherwise. Those are very safe assumptions. But again, just for broader picture, binary search trees and heaps are abstract data types that can be implemented in different ways. A linked list is not an abstract data type. A list is an abstract data type. A linked list is an implementation of the list abstract data type. So a linked list is always nodes. And if I were to say something like a linked binary search tree, that would be with nodes. But generally, binary search tree, you can assume nodes, and heaps you can assume arrays, unless we very, very explicitly say otherwise on the exam. Trees, basic definitions, be familiar with that. Be familiar with how to do traversals. Be familiar with binary search trees. The difference between a binary... Make sure on the exam that you're very careful about understanding binary tree is not equal to binary search tree. They're both binary trees, but the binary tree does not make any assumptions about order. Binary tree, no assumptions about order. Binary search tree, always sorted. Now, I want to be clear, sorted does not equal balanced. These are two very, very different things. A binary search tree will always have the elements. If you do an in-order traversal, those elements will always be sorted. However, you can have binary trees that are not balanced. Binary search trees that are unbalanced. So binary search tree and linked list. In a standard binary tree, can you have duplicate values? Generally, no, and you should assume no, unless we very, very explicitly say this binary search tree can have duplicate values, and duplicate values are stored to the left. Unless we say something like that, the answer is very much no. And I will say that I can't imagine we would write such a question, because I've never used if you're using a binary search tree, you're generally performing set-like operations, and set-like operations don't want duplicates. Otherwise, you would just implement something like a sorted list structure. I can think of reasons you would do it, but wouldn't be common. Is the value added first always the root? First, let me answer K-Stat's question. K-Stat asked, so binary trees do not have the same left is less than. Correct. No assumptions about order. Make very sure that if you do not see the word search, that you are not assuming that it is a binary search tree. If you just see binary tree and the word search is not there, do not make the assumption that left is less than and right is greater than. Second, Edme Folan, is the value added first always the root for a BST? That's actually the answer. The short answer is, for the purposes of our class, where we haven't talked about balancing algorithms, yes. That's the short answer. For the purposes of our class, for the purposes of the exam, where we have not talked about balancing algorithms, that is correct. But the longer answer is no, and I'll just very, very briefly explain why. Let's say that I have this binary tree, or binary search tree, 5, 7, 10. This tree is unbalanced, because the height of the left is 0, the height of the right is 2. And the way you would fix it is you would do something called a left rotation, where 5, instead of being the left parent, would become instead of being the parent, 5 becomes the child of 7, specifically the left child, and that's how a balancing algorithm would work. And again, not on the exam. Not exam. Want to be really clear. This is not on the exam. Just in this case, the root changed. The root went from there to there. But for the sake of this class, you're not going to be doing anything like this. What about rotation? So that's what we mean. We haven't talked about rotations. So you will in 2150. You'll talk about AVL and red-black trees. I've always been a fan of AVL trees. I think they're fun to work with. They're fun little coding projects. But certainly not in this class, not on 2150. Or, sorry, not in 2110. Not at all in 2110. So like homework 6, where you not only shouldn't do balancing, in fact, if you do balancing in homework 6, it will break our tests. So no balancing in homework 6, then yes, the first node added is the root. And of course, you also don't have delete in homework 6. If you had delete, then certainly the root could change, because you could delete the old root and replace it. But but we took that out because, again, let me be really clear. Like, the most common grade on our homework last year was like 93%. That was the most common grade on homework 6. About a third of the class had 93%, and only about a sixth had 100%. Actually, no, it was more than half the class had 93, and only about a sixth had 100. That 7% was all delete, because delete sucks. And you should be familiar broadly with how it works. The idea, again, is that you find either the next largest node, the successor, or the next smallest node, the predecessor. And you replace it and do some swapping and things like that. That's actually really hard to code. So that's why we took that out of Homework 6. If the class weren't online, we would have left it in. But the class is online, and everyone's already miserable, so we wanted to kind of throw you a bone there. And then heaps, be familiar with how to use them. Notice I didn't say how to write code for them, but you should understand how they work, how the arrays work, how to perform and add and remove. You should be certainly familiar with the pseudocode of add and remove, and I'll let you fill in any blanks or assumptions there. With that, are there any questions about anything on this slide before we go into overtime? Overtime being, I just answer whatever questions are asked in any order. But I want to give people a chance to ask this first. Well, I'm going to keep going as long as I can, / as long as there are questions. Yeah, no, so will the material be recorded? I'm just going to upload this. I'm still streaming. So keep in mind, anytime I'm streaming, it's also recording. Because all I do is I just export the videos from Twitch to YouTube. That's all I do. All right. Well, with that, I have a question for you. Give me 1 second to pull it up. Let's see if I can find it here. Yeah, it's going to take me. Can you walk through the pseudocode for a heap? No, but if you ask me, because again, that's a bit broad. If you ask about a specific step, certainly I can explain it. But again, that's actually a whole lecture, and I did cover. That's about 20 minutes of material, and I did cover it then. So I'm happy to answer specific questions, but I'm not going to just go over the whole thing again. Again, just for the sake of time, and again, because you can go back and watch the previous lecture. But give me 1 second, because I want to give you a test question. I just need a second to find it, because this was an exam that I gave a while ago. This was an exam I gave back when I was teaching intro programming. Let's see, I'm looking for J.J. Abrams. Perfect, here it is. All right, I wrote a question. So actually, what was funny about this, because I'm a child and I'm amused by silly things, is I like to write exam questions where the function does something that we covered in class, but the variable names don't match up with it, so they have to deduce what the function is. This was actually a copy and paste of a question from an exam three exams ago, and the students, we did release the previous exam, students could see it, but I changed the names so they didn't recognize it, and this was just me entirely making fun of J.J. Abrams. And in hindsight, Star Wars Episode 7 was the best of the new trilogy, and that's kind of sad. But this was me making fun of his Star Trek and Star Wars reboots. And my question to you is, what do I get when I call Nostalgia 1-2, Nostalgia 2-1, Nostalgia 12.5, and Nostalgia 12 or 22.6. So that's the question. And again, these arguments pass in, so arg0. So for example, for Java, Nostalgia 1.2. arg0 is 1, args1 is 2, whereas down here, this would be arg0, that would be args2. So try to work this out with each other. See if you can come to an answer. Don't post it yet. I'll ask for posting. But try to do just this part. Yes, I'm effectively calling lens flare 1.2. Correct. And then I'm printing whatever the output is. So I'm calling lens flare 1.2, and then I'm calling lens flare 2.1, and then I'm calling lens flare 12.5, and then I'm calling lens flare 22 and 6. Hang on. Don't post the answers yet. I'm timing you out only for 1 second, just to purge. Those may not have been the correct answers. In fact, they weren't. No, they may very well have been, or they may not have been. They may have been. Maybe they weren't. Nah, they probably weren't. No, they probably were. There. Now I've confused everyone, so no one knows what the hell I'm talking about, and no one even remembers what the answers were. Mission accomplished. Try to work on this for a bit. What I would say with tracing recursion is sometimes you may recognize a pattern that can let you more quickly evaluate what's going on. And if you recognize that pattern, you're certainly welcome to use it. But generally, I would say the first few times, certainly you have to trace kind of the long way. Are you going to release any practice questions? No. It's hard enough to write one exam that's effective and covers the material we want. Writing 2 exams in the same time frame is just it's difficult. How are runtimes and binary trees? So with a binary tree, because there's no order, everything is O of n. Because, like, let's say you're looking for the value 7, you have no clue if it's left or right. So the only way you can do things is with an in-order traversal. And the in-order traversal is O of n because you're visiting n nodes. So everything's O of n. Now with a binary search tree, remember, a binary search tree, it's only log n if the tree is balanced. If we do not stipulate that the tree is balanced, you may not necessarily be able to assume that it is balanced. Apologies for the Discord ping. Why don't we release the old exams? Because the old exams... so here's why. I'll tell you the exact reason. It's because while students tend to score higher if you release previous exams, it actually hurts their long-term learning. There's more than enough studies that show that if you're actually measuring long-term learning and not exam performance, but rather the how much the student actually takes away from a class in terms of skills, exams encourage practice exams encourage previous exams, releasing previous exams encourage short-term memorization and cramming, which is bad for long-term learning. as opposed to the most effective way to study is to practice the material. So if you, I'm going to give another minute and before I give the answers to this question, and in that minute I'm going to go on this little rant. They've done studies where what they've done is they've given students a short piece of text, and from that short piece of text they then ask them, okay, we're going to distract you for 2 minutes, read it again, read it again, read it again, read it again, and then do a test on it. And the students did really well. And then they said, okay, same short section of text. This is not just for CS. This is for literally all learning. For the same students, they gave them a separate piece of text, but instead of having them reread it again, they had them talk about it, they had them write everything they knew, and they had them write everything they knew again. They never let them read it a second time. And on the quiz, they did slightly worse. But a week later, they gave both those students the same tests. The students who read 4 times got like a 10%. The students who wrote everything they knew, they did practice. They took the initiative. They weren't just passively rereading. They were actually writing things down and interacting with the material. Those students did significantly better a week later. They did almost as well as they did the first time. So this is why there's studies that show that the practice exams certainly improve short-term exam performance. But the trade-off is it actually does have a detriment on long-term retaining. So that's why. Anyway, all right. Answers. Ready? Everyone have your answer typed? 5, 4, 3, 2, 1, go. All right, we're seeing 1024. We're seeing 1045, 1024. A lot of 1024. Does anyone know what this method does? What does this method do? Modulus, exactly. It's the modulus function. Rebooted with unnecessary extra language, just like a J.J. Abrams movie. So, real quick, I'm going to try to do this in Notepad, and if this doesn't work, then we'll go from there. I'm only going to trace, for the sake of this time, Nostalgia 12.5. So, Nostalgia 12.5, that's going to... So, we have Nostalgia 12.5. That's going to have 2 variables. That's going to have lens flare equals 12, and... That's going to call lens flare 12.5. So lens flare 12.5, that means emo Spock is 12 and Super 8 is 5. We hit this line, just so I can highlight. We hit this line, emo Spock is not less than Super 8, so we do not enter this if statement. Rather, we return lens flare, emo Spock minus Super 8. So emo Spock minus Super 8, that is lens flare 7, and then Super 8, 5. This is me making fun of the first Star Trek reboot, which actually wasn't that bad, truth be told. But I didn't like the fact that they made Spock this like super brooding, emotional guy. And yes, I'm gonna go rant about Star Trek at some point after this. All right, so we call this again. The second one was all the problems that Star Wars 7 had, and I'll save that for after the exam material. I'll just go on an angry rant about why I don't like J.J. Abrams movies. Anyway, so now we have this call. Emo Spock, still not less than 8, so we call again. Same process we call lens flare with 7 minus 5, so 2. 5 doesn't change. Now we're in this function, and we return emo Spock because emo Spock is less than Super 8, so we return 2. The 2 gets returned to here, and we were, at this line, we were here, so we say return the output of the function that was created. What? Why is my lighting so weird all of a sudden? I don't know why I was suddenly holy on my camera. It was really weird. Anyway. So that returns 2, so that returns 2. So we end up getting 2 back here stored in this variable, and we print 2. So it's the modulus function. So I kind of like this question. Any other questions? Yeah, it was weird. Like, I looked at my camera and it was just like super yellow. I don't know why. Maybe holy is not the right word. Maybe, I don't know. Yes, the correct answer is 1024 because that 1 mod 2 is 0, 2 mod 1 is, or excuse me, 1 mod 2 is 1, 2 mod 1 is 0, 12 mod 5 is 2, and 22 mod 6 is 4. All right. Any other? All right. So now the last chance before I get into ask any questions you want about anything, because I will do that. I like to normally do this on the last day of class before the exam review, but because of the abbreviated schedule, we didn't have this. So, exam questions for the next 2 minutes. And then from there, any questions about anything. And I'll go on my rant about why I don't like J.J. Abrams movies. And I say that's actually too broad, because I really like 10 Cloverfield Lane. Well, all except the last 5 minutes of it. One minute to get questions in, and then it's questions about anything. You could ask why I'm terrified of AI, for example. Which I am. Why do we use heaps again? So the primary intent of the heap, and since I have time, I'll go ahead and look at the slides for heap again. So this might answer the question that was earlier about the pseudocode, which technically we didn't write pseudocode. We just described broadly how it works. Give me 1 second. You can see how... Oh, wait, I have the wrong... Hang on. I'm on the wrong account. I have to log in, and I'm not showing you all my password. Oh yeah, Orcs Must Die is amazing. Orcs Must Die is so fun. It's a really good game. Orcs Must Die combines like Dynasty Warriors with a tower defense game, and I never knew I wanted that until I played it. And I'm really upset that there aren't more games like Orcs Must Die. And I didn't like Orcs Must Die 2 because I don't really like co-op games that much because all my friends are worse at me than at video games, so it's frustrating. All right, let's see. Where is... That's the thing. I will not play any game that has microtransactions. I will play games with DLC. I don't have a problem with DLC. If the devs want to add to a game that I love and give me more hours with it for like $10, I am totally fine with that. Even day one DLC. Don't care. But if it's like, oh, and you can spend $5 in advance in this game, I won't play it. I won't play it. Um, yeah, that's just where I'm at. And so that's why I don't buy shooters anymore, because all the shooters have just billions of microtransactions for competitive advantages. Anyway, so the primary purpose of a heap is to remove the minimum or maximum. So a heap is either a min heap or a max heap. The min heap has the minimum value at the root. The max heap has the maximum value at the root. And the point of removing an element from a heap is to remove either the min or maximum. So a heap is a data structure when you want to get either the minimum value or the maximum value repeatedly. Controversial opinion. I'd happily pay $80 for a video game if it just had all the features and no microtransactions. If Star Wars Battlefront 2 just had progression unlocks, and that was it, just progression unlocks, I'd happily have paid $80 for it. No questions asked. But to give it a $60 video game and then to say, oh, and if someone drops $30, then they're going to have an advantage over you, then no. No, hell no. It's why I won't play shooters. And granted, I'm being hypocritical here because I play MOBAs, and MOBAs can very much be pay to win. You buy heroes, which you can get through time investment, but you can also short circuit it. But at least someone else's Raynor is just as good as my Raynor. Where can we find the class evaluation? On Collab, under your home tab, you should see it there. Collab, and then on the tabs at the top, click home, and then on the left banner at the bottom, you should see course evals. Oh my god, that Reddit post was amazing. Here's the problem. So, all right, I'll just go on this rant right now. Here is the problem with free to play. And it's the same problem that the alcohol industry has, and it's the same problem that the drug businesses have. And it is that if everyone drank in moderation, the alcohol companies would lose a ton of money. The reality is there is a small percentage of their base which makes the majority of their business. And those people are people typically with dependencies. And by that I mean the end purchaser. So not like a bar, because technically the bar is purchasing. It's the end user that ultimately, it's very disproportionate. You have a curve. And so there's this term called the whale. And the idea is every business has a small number of whales, and those small number of whales provide more business than everyone else combined. And what it encourages is it infects the entire game design process. Because the entire point of the game design process is to trigger the whales to make purchases. And so it is intentionally designed to trigger addicting behavior in order to get people to spend money on the game, a small number of people to spend inordinate sums of money. That's literally the entire design. And I think it's immoral. So that's why I won't participate in it. I think it's incredibly immoral. This is why, like in Overwatch, when you get a loot box, it comes down and makes this big explosion and has all these satisfying ping noises. And then when you get a yellow, like, oh my god, it blows up and it's glowing. And it's the exact same thing as slot machines. Slot machines make those same noises, those same lights and sound that are triggering this ape brain that we all have to drop more quarters. That's all it's doing. And it's frankly disgusting. Because they know the harm it does. It's not like, oh no, we're bankrupting a small number of people who are we're playing off the addictive personalities of. Oh no, are we really doing that? Oh, our mistake. Bullshit. They know they're doing it, and so that's why I have a real concern with where gaming's going. That's correct. Sounds like deep psychological manipulation that only works on a few people. Ding ding ding. And Fallout 76 did this. Like Fallout 76, like, oh, you can buy thing. So Fallout 76, they make food rot inordinately quickly. Food that you need to have. They make food go bad extremely quickly, and then they sell you a solution. So they make the game worse and then sell you something at a premium that fixes the thing that they broke in the game. Because it's not like food went bad in other Fallout games. Why are you scared of AI? Dude, I'm from West Virginia and a Fallout fan. How do you think I felt about Fallout 76? Um, why I'm afraid of AI? Because intelligence is the most valuable tool that we have. Intelligence is by far the most valuable tool that we have. If we are going to get through this COVID-19 thing, it's going to require systemic intelligence. Because the reality is, we cannot just shelter in place until there's a vaccine. You cannot have the entire world shelter in place for 18 months. Whether you like that or not, it cannot be done. You will have a depression worse than the Great Depression in the 20s if we do that. That's not. This is not a take to reopen now. I'm not saying that very much. I'm not saying that. But we need an intelligent way to bring the world back online in increments in order to protect vulnerable individuals, especially vulnerable individuals, from COVID-19. We need a way to do that. That's going to require intelligence and planning on a scale that we've never done, because there's never been this many people on the planet, and this widespread a pandemic with this many people on the planet. So why am I terrified of AI? Because that intelligence, as long as we have problems to solve, we will develop better and better intelligence to solve them. But what is intelligence? Intelligence is not just some abstract thing. Intelligence is how. Intelligence is how. What do I mean by that? In theory, I could take a ball of hydrogen atoms, as many hydrogen atoms as I need, and I could form that computer and those monitors. And me. I could make a clone of me given enough hydrogen atoms. That's all we need, because that's all the universe had. Right? Effectively, lots of hydrogen atoms. The problem isn't that it can't be done. The problem is we don't even begin to know how to do that, because how do we collect enough hydrogen into one place? How do we control the hydrogen to produce the right things? Etc. If we had that intelligence, then we could do it. So now, intelligence does not require consciousness. That's probably the most controversial thing I'll say, but I think it's absolutely true. We already have superhuman narrow intelligence. The best chess-playing human will never come close to beating the best chess-playing computer again. It will never happen. The best Go-playing human won't beat the best Go-playing computer. Won't ever happen. That's a one-way path. Once things become the realm of computers, they stay there. Now, what computers don't have, and this is the key, this is what everyone always brings up, and they're right so far, is general intelligence. There's narrow intelligence and there's general. The best chess-playing computer in the world is very, very bad at tic-tac-toe. And I could probably beat it at tic-tac-toe. The computer couldn't even play. It would just crash. It would have no clue how to deal with it. Until someone trains it to. But we're still talking narrow intelligence, because you're talking about learning in one space and applying it there. Except we're starting to see the dawn of general intelligence AI with things like teaching AIs to play different Atari games they've never seen before based on their past experience. Once you break that gap of being able to learn across spaces, at that point I think you're dealing with an entity that, while not necessarily conscious, and in fact I would be surprised if it were conscious, An entity that would be significantly more intelligent than us. Right now, I am in a new housing development. They're doing construction kind of down around the corner from me. When I moved in, I noticed there was an anthill in one of those plots. There is no longer an anthill there. There's a house there. What do you think happened to the ants? They were exterminated without a qualm. I mean, they probably just poured concrete right on top of them. The ants died. That's just a reality. Why? Why is that okay? Is it well, because we are so superior in intelligence that we think of the ant as barely even conscious. And so whenever their goals conflict with ours, we don't care. We just do our goals. And so what happens when there's something significantly more intelligent than us and our goals conflict with it? I don't know. Further, even if this is an AI in a box, an AI that doesn't have cyber physical systems, that only has a monitor to display, what is persuasion? Persuasion is an intellectual practice, right? How do you persuade someone can be described intellectually, the techniques used, etc. You're talking about an AI in a box talking to a scientist, and it would be the most persuasive entity in the entire world, given enough practice. So the point being, I don't think we have given any thought to what will happen when we are nowhere close to the most intelligent thing on the planet. This does not require robots to be spontaneously malevolent. This only requires intelligence explosion that leads us to take actions we don't understand because something smart in us tells us to take them. And if those goals conflict with our own, what could happen? Could we accidentally produce, say, a super virus that wipes out humanity? Maybe. Not necessarily 100% our fault. Could be because of volcanic eruptions. It could be because of a meteor. Those wouldn't be our fault. There's a lot of ways it can be our fault, but yeah. So that's why I'm terrified of AI. And there's also something to be said about, and this kind of gets into my whole like perspective of we exist within the universe to observe it because of our consciousness and what is consciousness, etc. And and what happens if you have intelligent entities that aren't conscious? That is to say, the universe continues and is changed by entities with intent, but without consciousness to observe their outcome. That's always kind of interesting to think about. I think we only have a few 100 million years. I don't think we have billions of years. I think we only have a few 100 million years. I could be wrong on that. It's been a while since I've taken astronomy or watched. I mean, I know the mechanics. What happens is effectively there isn't enough free hydrogen to fuse into helium, and so the sun um, starts to contract, and the pressure causes helium, or the pressure causes helium to fuse, which produces more energy, which then causes the sun to expand, and then it's hotter, so it's fusing helium and hydrogen into lithium and magnesium and heavier elements, and then it just until you get to like carbon fusing into iron, and I think that's the last stage of our sun. I don't think our star is. If I remember, iron's like the hottest it could do, and at that point, it's actually using more energy to produce iron than the fusion produces, and that's when it starts to collapse. But I think it's when we start fusing helium that it would grow enough to certainly, if not consume the Earth, it would certainly annihilate all life on Earth. Um, Earth would be like Mercury at that point, one would imagine. All right, down to 27 people. Well, this is what I'll say. This is always kind of the thing I decided that I'm going to say at the end of classes to people. And if someone wants to share this, they're welcome to, but whatever. Um, 2 years ago, I do you remember someone asking if water is wet? No, I don't. What do you think about cybernetics? I mean, I actually am weirded out by that question in terms of I don't know how to answer it because when I start thinking about human like using cybernetics to improve our brain, there's certainly an ick factor there, but I don't know if that ick factor um, is because I actually can think of a reasonable objection intuitively, or because I'm immediately like icky and therefore I rationalize why I don't like it. It's hard to tell how I feel about that. I don't actually have a strong feeling. So I will say this: 2 years ago, due to various reasons that were beyond my control, I was told that I might not be retained for a year at my job at the time, and it was the most stressful summer of my life. I did not sleep very well. I would oftentimes wake up in panic because I thought, how am I going to pay the rent? How am I going to feed my cats? Blah, blah, blah. I ended up being retained. Everything was fine, but there were. Did I just lose all internet access? My upload rate's probably really, really low. Something's going on. One sec. Internet pooping. Just in case you can't hear me. Um. Alright, it's coming back. Anyway, at that point, I was convinced that I had failed as just a person. And I really mean that. I was convinced I couldn't do this job. Um, and you're gonna hit some point like that in your life. And the fact is, I'm still doing the same job. I decided after I was retained for a year to look for employment elsewhere, which is why I'm here at UVA now. But yeah, I was at that point. It was not a great moment of my life. What I will say is never be at a point where you think that you're beyond improving your circumstances. Um, because I was there and I managed to get past it. Wow, I'm dropping basically every frame, aren't I? One sec, let me restart the stream.